Okay, so we're going to be starting section 16.2, which is Introduction to Functions. So our concepts we're going to go over are definition of a function, vertical line test, function notation, finding function values from a graph, and the domain of a function. Okay, so looking at topic 1, the definition of a function. I'm going to go ahead and move over here so I can see everybody. Okay. And everyone can see this fine in the back? Light-wise? Okay. Definition of a function. Given a relation in x and y, we say y is a function of x. If for each element x in the domain, there's exactly one value of y in the range. So what this means is that no two ordered pairs can have the same first coordinate and different second coordinates. Okay? Meaning, if we are looking at our x's, they cannot repeat. So if we have, if x's repeat, then it's not a function. It does not matter if y's repeat. Y's can repeat, just not the x's. Because when we are looking at coordinate points with the x repeating, we will get a vertical line when we graph those points. And when we look at the concept of the vertical line test, that will again disprove that it's not a function. Okay. So looking at these examples, starting with example 1, remember we have these maps that we talked about finding the domain and range last time. Now we're just going to take this map and we're just going to write the coordinate points. So looking at this, how many coordinate points are we going to have?
4.
Good, we're going to have 4 because there are 4 arrows coming off the x's. So our first one's going to be 1, 3, 1, 4, because notice that there's 2 arrows coming off the 1, 2, -1, and 3, -2. So once we have all of our ordered pairs listed, we're going to go check and see if any of our x values repeat. Do they repeat in this problem?
Yes.
Yes, we have 2 1 values here. Since they repeat, is this function a function or not a function?
No.
Not a function. I should say is this example a function or not a function? So not function. And that's our answer here. That's what we're checking. We're checking if these maps are functions or not. Looking at number 2, how many ordered pairs are we going to have? 3, because of the 3 arrows coming off the x. So our first one is 1, 4, because of that arrow going from the 1 to the 4. 2, -1, and 3, 2. Once we have our ordered pairs, we're checking our x's. Do any of our x's repeat? No, so that means it is a function. So function. Okay, because we're checking if any of our x values repeat. Number 3, how many ordered pairs are we going to have? Good, we're going to have 3 because of the 3 arrows coming off of it. So we have 1, 4, 2, 4, and 3, 4. Notice how every single one of these x's are going towards the y value 4. Does that matter when we're checking if something is a function? No. So looking at number 3, is this a function or not a function?
Yes.
It is a function because if we look at the x values, 1, 2, 3, none of them repeat. So again, we're looking at these x values here. None of them repeat. And then looking at our last map on number 4, how many ordered pairs are we going to have? 3, because of the 3 arrows. So we'll have 2, 12, 6, what number? 10. And then 7, 13. Again, looking at these points, is this a function or not a function? It's a function. So those were our examples looking at maps. Now we're going to look at number 5 and 6, which is just a set of ordered points. So they've already listed the order points for us. So on number 5, do any of our x values repeat? No, so what does that tell us? It is a function. Okay. What about on number 6? Function or not a function? Why? Good, because the -1 repeats on these x values. That means it is not a function. Okay. So this is how we determine if something is a function versus not a function when we are given our coordinate points. Okay. In the next concept, we're going to look at how to determine that if we are given a graph. Okay, any questions on concept 1? Okay, concept 2 is the vertical line test. The vertical line test says consider a relation defined by a set of points in a coordinate plane. So what this is saying is consider a graph. The graph defines y as a function of x if no vertical line intersects the graph in more than one point. So all we're doing is we're going to be drawing a bunch of vertical lines, and if that vertical line passes through more than one point, so for example right here, how it passes through those 2 points, then we say it does not pass the vertical line test, so it is not a function. Okay, so it has to pass the vertical line test in order to be a function. So if we look at this example over here, notice when they draw these vertical lines, that no matter what, they're only passing through one point in the function. So that means it is a function. Okay. So this is that same concept of x's cannot repeat. Because if we were to label these points right here, where it is not a function, okay, let's label this A and B. What would point A be? 1, 3. And what about point B? 1, 4. Notice how the 1's repeat, okay? So instead of having to write out all of these ordered pairs, we just use the vertical line test. Okay, so let's look at some examples. So example 1, we have an ellipse. What I'm going to do is I'm going to draw a couple vertical lines on this graph. Okay. And then I'm going to see where these vertical lines cross the function. So this crosses the function here, 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 and here. Would you say this is a function or not a function? Not a function. Why? Good, it intersects the graph twice. Not a function. Okay, we're going to do the same thing for number 2. We're just going to draw a bunch of vertical lines. We're trying to cover as much of the graph as possible. Okay. So then let's see, this one crosses here, here, wherever this vertical line intersects that blue line. The blue line is our graph. So looking at number 2, is this a function or not a function? Good, it's a function. Why? Good, it only crosses the graph on that vertical line one time. Okay, what about number 3? Function or not a function?
Function.
It's a function. Why?
It passes the vertical line test.
It passes the vertical line test, and I can test that here. Let me draw a couple vertical lines. Notice that no matter where I draw the vertical line, it only crosses my graph at one point. So that means it is a function. What about number 4?
No.
Not a function. Why? Good. It does not pass the vertical line test because it crosses that function more than one time. So notice that these ones cross 3 to 4 times on this graph. So this tells us that this is not a function. Okay. Any questions on vertical line test? Now let's look at the concept of function notation. Let me check. I think I left this blank for notes. Yep. Okay, function notation. When we are talking about a function, our function is usually written in the terms y is equal to ax plus b. Okay? Where a and b are just numbers and y and x are our variables. When we're talking about function notation, instead of using y, we use f of x, and that looks like this. F of x is equal to ax plus b. Y and f of x are the same. So if you see f of x, think y. If you see y, think f of x. And I'm going to write that here, that this is f of x.
Okay. In this case, though, when we're just seeing the f of x, that's just signifying that it is a function in this case, correct?
Correct.
So then look for the pattern of no repeating x's in that case.
Correct.
Okay.
Correct. Yes, so when we are looking at function notation, if we see f of x, these are already functions, okay? So we're already dealing with functions. We're just going to break down these functions and plug in points for x, okay? What if we had something that looks like this? How would we say that? That's the function what? G of b, right? Function g of b. Okay, what about this? How would we say that? H of 2. This is the function h of 2. Okay, so we're going to keep that in mind. Let me go and erase that. Okay, so looking at example 1, we have, what is this right here? G of x is equal to 1/2 x minus 1. So this tells us this is the function g in terms of x, okay? If we were to try to find a certain number on that function, that is when we see these numbers here changing our x value. So in the first one, instead of having x in our function, we're going to have what? 0. What about on the second one?
2.
Third one? 4. So what are we doing with these numbers? Plugging it in for x. Okay. So first one, g of 0. So g of 0 is equal to 1/2 times 0 minus 1. So we're going to solve that. 1/2 times 0 is 0. 0 minus 1, negative 1. So that means g of 0 is equal to negative 1. How could I write that as a point? Close, not negative 1, 0, because remember 0, negative 1. Because this is my x, this is my y. Okay. Both answers are correct. It's just going to depend on what the problem is asking you for. If the problem is asking you to put your answer as an ordered pair, then you would write this one, because this is an ordered pair. If the question is just asking you to solve for g of 0, you would just put -1. Okay, so that's going to pop up on Alex, so just in case they mark your answer wrong, just know, look what they're asking for. Okay, for B, we're plugging in 2 for x now. So g of 2 is equal to 1/2 times 2 minus 1. Half of 2 is 1. 1 minus 1 is 0. So we have g of 2 is equal to 0, or what's my ordered pair? 2, 0. Circling both because they're both the correct answer. Just written in different forms. C, g of 4 is equal to 1/2 times 4 minus 1. Half of 4 is 2. 2 minus 1, 1. So g of 4 is equal to 1, or what's my ordered pair? 4, 1. And then our last part on D, we have g of -2. So g of -2 is equal to 1/2 times -2 minus 1. Half of -2 is -1. -1 minus 1 is -2. Good. So g of -2 gives us -2, which means our point is -2, -2. So this is function notation. So, okay, what am I trying to ask? Function notation not only shows us how to plug in these x values, it's also giving us a bunch of what? What did it give us a bunch of these? Gave us a bunch of points, ordered pairs. So that means we could use these ordered pairs and create a what?
Graph.
A graph, okay? So we use function notation to get ordered pairs to create a graph. Okay. Just keep that in mind for the future. These problems are not asking us to graph. They're just having us plug in numbers. Okay, so for number 2, how do we read this? F of x. F of x is equal to -2x minus 3. Go ahead and solve for f of 1. Give you guys a few seconds to do that, and then we'll go over it. Remember, you're plugging in 1 for x. Good, yeah, -5. So if we were to write that as a point, it would be what? 1, -5. So let's plug that in. F of 1 is equal to -2 times 1 minus 3. This gives us -2 minus 3, which is -5. So f of 1 equals -5, or the ordered pair 1, -5. Okay. What would we get if we plug in 0? 0, -3, because that 0 would be multiplied by that first part, and it would cancel, and we would just have that -3 left. So f of 0 is equal to -2 times 0 minus 3, which is -3. And then we said that that point would be 0, -3. Okay. Go ahead and plug in -3, and when you get the answer, just shout it out. So we're plugging in -3. -3, +3? Okay, so we got 6 minus 3. Yep, so we got 3. So f of -3 is equal to 3, which is the point -3, +3. Okay, Same thing with fractions. We're still plugging in those in for x. So we have f of 1/2 is equal to negative 2 times 1/2 minus 3. What'd you guys get?
-1.
Good, negative 4. If we were to write this as a point, would we have a fraction in our ordered pair or a decimal? A decimal. So how would we write that ordered pair?
0.5,
Good, 0.5 comma negative 4. The reason I changed it into a decimal, it's easier to plot a decimal on a graph than it is a fraction. This fraction's easy because we all know what 1/2 is, but if you had something like 7/8, right, it would be easier to turn it into a decimal. Okay, any questions on 1 or 2? Okay. Now looking at 3, what do we have that's different? We have 2 functions. We have the function, what?
Function of x squared minus 2x.
So f of x and g of x. Okay. So when we're looking at our problems and it's having us plug in all of these values for x, we have to pay attention to what function it wants us to plug into. Okay, so now it's not only going to be that one function, they could change it up on us. Okay, so we got to pay attention to both parts. So for A, what function is it having us plug into? F function, right? We're plugging into the f function. So let me just write the f function, which is that x squared minus 2x. And what are we plugging in for x? T. So we have f of t is equal to t squared minus 2t. Can we simplify that?
Yes.
With the knowledge we've only learned in this course so far? No. Yes, in future lectures, sure, we could, but right now, we haven't learned that yet. So this is as simplified as it can be, so that means we turned our f of x function into an f of t function. So all it did was change the variable from x to t. Okay, what function are we using in B? The g function. So g of x is equal to 3x plus 5. What are we plugging in for x? W plus 4. When we plug in that w plus 4, are we going to just plug it in or are we going to plug it in with parentheses? Parentheses. So g of w plus 4 is equal to 3 times w plus 4 plus 5. Notice I put the parentheses because if I did not, this would read 3w plus 4. Okay, but we're plugging in that whole sum of w plus 4. Can we simplify this? Yes, what can we do? Distribute that 3. So we have g of w plus 4 is equal to 3w plus 12 plus 5. Can we simplify? Good, we could simplify by adding these two together, and we get g of w plus 4 is equal to 3w plus 17. Could we turn A and B into coordinate points, into ordered pairs? So we could, it just wouldn't look like a pretty ordered pair, right? It would look like for A, t comma t squared minus 2t. Okay, that doesn't help us with graphing because we don't know the values of t. Okay, same with B. We could put that into an ordered pair of w plus 4 comma 3w plus 17, but it would not help us with graphing anything because we don't know the values of w. Okay, so it's possible, but it does nothing for us, so we're not going to do it. Okay. For C, what function are we using? F function. So we're using f of x is equal to x squared minus 2x. What are we plugging in for x? Negative t. Am I going to plug it in just negative t or negative t with parentheses? Parentheses. Why?
To keep the negative, like, make sure you distribute it properly.
Correct. To make sure that negative gets put into the problem correctly. So f of negative t is equal to negative t squared minus 2 times negative t. Can this simplify?
Yes.
Yes. What could this first part simplify to?
T.
T squared, right? Because this negative gets squared, which turns it to a positive, and then that t gets squared. So f of negative t is equal to t squared. What about that next part?
Plus 2t.
Plus 2t, because a negative times a negative is a positive. Okay, any questions on number 3? Okay. On number 4, we are only dealing with one function, and that function is what? G of x. So for part A, what are we plugging in for x? A. What about for B? What are we plugging in?
X plus H.
X plus h. And then for C, negative x. Okay, so let's go ahead and do that. So g of x is equal to 4x minus 3. Instead of x, I'm putting an a. So what is this doing to the problem? It's just switching a for, or x for a. G of a is equal to 4a minus 3. Can we simplify? No. So that's our answer. For B, are we going to plug in x plus h or x plus h in parentheses? Parentheses. So we have g of x is equal to 4x minus 3. So if we're plugging in g of x plus h, we would get 4 times x plus h minus 3. Can we simplify? Yes or no?
Yes.
Yes, we can. What can we do? Distribute. So g of x plus h is equal to 4x plus 4h minus 3. Can we simplify?
No.
No. Why can't we combine 4x and 4h? Two different variables, so they are not like terms. Good. Then lastly, for C, are we plugging in that negative x with or without parentheses? With parentheses. So g of x is equal to 4x minus 3. Plugging in a negative x, we get 4 times negative x minus 3. Can this simplify? Yes. What would this part simplify to?
Negative 4x.
Negative 4x. And then bring down that minus 3. Could we turn these into points?
If we really wanted.
If we wanted to, would it help us?
No.
No. Okay, so that's concept 3. Any questions? Okay, concept 4. Make sure I don't have any notes for this. No, okay. Concept 4 is finding function values from a graph. This seems to be the hardest part when we're testing over the first test. This is the part that a lot of people get wrong on the test, so we're going to go over this a little slow, just in case. So we have, on number 1, a graph with the function of what? H of x. Good. This is the function h of x. Okay. What do we notice that's happening on the left of that function? Good. We have an arrow here that tells us it's going to infinities on the y's and negative infinities on the x's. What does this tell us?
It stops, but does not include.
Good. It's going to stop there, but not include those numbers. So using that information, if we need to find h of -1, that -1 is again what variable?
X.
It's x. So we're going to find -1 on the x's. Okay, so that's right here. Okay, and we are going to find where that -1 falls on that blue line, right? The blue line is our function. So would we be going up towards our function or down? Up, and we would go to what y value? 2. So h of -1 is equal to 2. Okay, can we write that as a point? What's the point? So again, depending on what they're asking on the homework on Alex, you would either write 2 or you would write it as a point, and they should tell you which one they want. Okay, so what about for h of 2? That 2 is what variable? X. So we're going to go to 2 on the x's. Are we going to go up or down to our function? Up, because that's where our blue line is, and that's going to go to what value on the y's? 1. So that means h of 2 is 1, or we write that as what point? 2, 1. Okay. Now we are looking at h of 5. That 5 is what variable? X. Okay, so we find that on our x's. So right here, here's the 5. Are we going to go up or down to our function? Okay, let's just say we went up. Is there any blue lines up here? No, so that means our function isn't up. Is there any blue lines as we go down? Yes, and it stops right here at what value?
Does it though?
Yeah, we're going to talk about that next. So here on the graph, if we were ignoring that open circle, our answer would be -1. But since we have that open circle there, do we have a point that exists at 5, -1? No. So we would write that h of 5 does not exist. Okay? Doesn't exist. Or you could write the shorthand DNE. Does not exist. Okay? And this is usually where the mistakes happen. Okay? When you forget that this is not included. Okay, now on part D, it says, what is the value of x if h of x is equal to 3? So that 3 is what variable?
Y.
Y, because it says, what is the value of x? So that means that number is y. So we're going to do the same thing. But instead of finding 3 on the x's, we're going to find 3 on the y's. So we have 3 right here on the y's. Are we going to go left or right to our function? Left. Okay, and that's going to stop where on our x's? -4. So on D it says what value of x? So we would say x is equal to what? -4. How would we write that as a point?
-4, 3.
Good. Perfect. Okay. Last one says what value of x if h of x is equal to 0? That 0 is what variable?
Y.
Y. So we're going to go find y of 0, which is right here at the origin. Okay. And since we need to find the corresponding x values, are we going to go left or right? Both. Why are we going both?
Because it crosses 0 at 2 points.
Good. So if we go this way, it crosses at x at what point? -3. And if we go this way, it crosses the x at 4. So that means there's 2 answers here. So 2 points. So we have x is equal to -3. X is equal to 4. What would my 2 points be? How would I write that as points?
-3, 0, and 4, 0.
Perfect. -3, 0, and 4, 0. When my y values are 0, what's another name for these points?
X and Y intercepts.
Good, x-intercepts, because they intercept the x-axis, okay? That was just to see if you knew. We're going to talk about those in a couple more notes. Okay. Now let's look at number 2. Okay, so what do we notice on the left side of graph number 2? Good, we have this closed dot. What does that mean? Good. So if we did have a point there, would we say that the point exists or does not exist? It does exist. So because of that closed dot. So this is included. What about on the right side? Not included. So if we had a point there, would we say it exists or doesn't exist? Doesn't exist. Okay, so let's look at f of 0. 0 is what value? Or sorry, what variable? Yep, it's x. So we're going to look at x on 0, which is the origin. Are we going to be looking up and down or left and right? Up and down, because we already have the x's and we need to find the y's. So are we going to go up or down? Up. And that's going to be at what value? 3. So what would my point be? 0, 3. Perfect. Okay, what about f of negative 2? Negative 2 is what variable? X. So I'm going to look at negative 2 on my x's right here. Am I going up, down, left, right? Up. And that gives me what point? 1. So what is my coordinate point? Negative 2, 1. What about 5? 5 is our what variable? X. So it means we need to find y. So we're finding 5 on the x's, so it's right here. Which direction are we going to find our y? Down, because remember, y is up or down, x is left or right. So this goes down to negative 1, but is it included or not included? Not included, so what do we say the answer is for C? Does not exist. That's what D and E stands for. Does not exist. Okay. For D, it says, what is the value of x if f of x is equal to 0? So 0 is what variable? Y. So we're going to go to 0 y's, which is again the origin. But since we need to find x, which direction are we going? Left and right, because if we go left, we stop at a point, and if we go right, we also stop at a point. Okay. What point do we stop on the left side? Negative 4. What about the right side? Because it doesn't quite hit that 4. So what would you say that decimal is approximate?
3.75.
Sure, 3.75. Okay. If it does not fall exactly on that number, you're going to give me a good guess, okay, a good estimate. You wouldn't say 3.1 because that's farther away from the 3. So try to make it, so if you said like 3.8, 3.9, those would all be correct. A close decimal to the 4. So that means we are going to have 2 answers. So x is equal to negative 4 and x is equal to 3.75. So what are my points? Good, 3.750. These points, since my y value is 0, are considered which intercepts? X or y? X intercepts, good. Lastly, we have what is the value of x if f of x is equal to, is that a 4 or negative 4?
Negative.
It's a negative 4. Let me just rewrite that then, because I covered it. That negative 4 is what variable? Y. So we're going to find negative 4 on the y's. So negative 4 is right here. Okay, which direction are we going? Left, because that's where our function is. And that corresponds to what number on the x's? Negative 5. Is this included or not included? Included, so we say x is equal to 5, or our point of, what's our point?
X is equal to negative 5?
Yes, x is equal to negative 5. Sorry. So what's our point? Negative 4. Yep. Okay, so that's how we would find function values from a graph. Okay. That's if we are not given a function equation, okay, just given the graph. Concept 5 is domain of a function. To find the domain of a function, keep these guidelines in mind. Exclude values of x that make the denominator of a fraction 0, and exclude values of x that make the expression within a square root negative. So when we are finding the domain of a function, we are just focusing on the denominator. Okay? So what we're going to do is we are going to set the denominator equal to 0, because we want to find what values would make that denominator 0, and we need to exclude them from our domain. So our denominator here is that 2x minus 1. So I'm going to set 2x minus 1 equal to 0, and I'm going to solve for x. Okay. Doing that, I add 1 to both sides, and I get 2x is equal to 1. Divide by 2, and I get x is equal to 1/2. So what does that tell us? 1/2, is that in our domain or not in our domain?
Not.
It's not, because if we plug in that 1/2 in for x, it will turn the bottom of our fraction 0. And what happens when you divide by 0?
Nothing.
Yeah, but dividing by 0 does not exist, okay? Does not exist, okay? So in these type of problems, when we are working on the domain, we are going to be using the union sign. I think we talked about this, can't remember. So the union sign is what we use to combine two parts of the same domain. So combine parts of the same domain. Okay. So if we're looking at the entire domain of negative infinity to positive infinity, right? But we do not want to include that 1/2, we would write our answer negative infinity to 1/2. Would this be a parenthesis or a bracket? Parenthesis, because it's not included. Union, parenthesis again, 1/2 to positive infinity. So we took this domain, so this is the common domain, this is all real numbers, from negative infinity to positive infinity. But our function can't include 1/2, so we have to create two separate parts of our domain, not including the 1/2 and combining it with a union sign. So this right here is our answer. Okay. So pretty much whatever answer, whatever number we get when we set our denominator equal to 0, that's the number that's going to be going here every time. Okay, both these places. Okay, let's look at number 2. Number 2, go ahead and cross out that squared. That's a mistake. Should just say x plus 9, because we have not talked about factoring yet. X plus 9. So what are we going to do with that x plus 9? Set it to 0. So x plus 9 is equal to 0, which means x is what? Negative 9. Is that negative 9 included or not included? Not included. So how would our domain look? So negative infinity to negative 9, parenthesis or bracket, and then union, and then how do we start our next one? That same negative 9, positive infinity. This is our answer. This tells us that our domain is all real numbers except negative 9. Okay. Number 3, we now have a function that is not listed as a fraction. Instead, we need to follow the rules that are related to the square roots. So the only thing we need to know is that we can't take the square root of what number?
0.
No, we can take the square root of 0. What numbers can we not take the square root of? Negative. We can't take the square root of negative numbers. So that means we need to take this inside value and we need to find out which numbers would make this negative. Okay? So we would have t plus 4. We want to find out which numbers are going to make this negative. Negative means less than 0. Okay, less than 0. So if we were to simplify this and get t by itself, we would have t is less than what? Negative 4. How would we write t is less than negative 4 in a domain? So think back to when we learned about interval notation. How would we write this as interval notation? That you're thinking of the other one. Yeah. Yep. Would it be easier if we just drew a number line? Okay, on our number line, we put our negative 4. Are we going to have an open dot or a closed dot? Open. In which direction is it going to go? To the left. How do we turn that into an interval notation?
Negative infinity, or bracket, or no, parentheses.
Parentheses, negative infinity,
Negative 4.
negative 4, parenthesis. That is our domain. So when you are dealing with functions that have radicals, those square roots, your domain is going to look like interval notation. Okay? When we have the functions that have the fractions, like number 1 and number 2, your domain is going to have a union of 2 parts. Okay? Any questions on 3? Yes?
Is it always going to be the, like, t plus, it's going to be less than 0?
Yes, it's always going to be less than 0 because we want to find what's going to make it negative. That's why it's less than 0.
Okay.
Why is it not less than or equal to 0?
Then you'd be doing a square root of 0.
Yes, and does the square root of 0 exist?
No.
Yes. Square root of 0 is just 0, right?
Oh,
Square root of 0 is 0. So it does exist. Okay. For this function f of t is equal to t squared minus 3t. So before we start solving this, just imagine if you were to plug in any number on the number line, negative, 0, or positive, would this ever give you something that is not valid? For example, a fraction with a 0 on the bottom or a square root with a negative. Would it ever give you something that's not valid? No, it would never give you something, right? So in these cases, and it's most cases when you see this squared here, When you see that squared of a function, that means we're dealing with a quadratic equation. Okay, so this is a quadratic equation. And we know that because of the exponent of 2. Quadratic equations either look like this, a right side u or an upside down u. The domain for these functions are always all real numbers, every single time. So the domain is equal to all real numbers. Did we talk about that R?
Yes.
Okay, all real numbers. I'll also write it out. Okay, all real numbers. What's a way to write that in interval notation?
Negative infinity with parentheses, positive infinity with parentheses.
Perfect. Negative infinity to positive infinity is how you would write that in interval notation, just in case it asks that on the homework. Okay. Number 5. What are we going to do with 5 since we have a fraction?
Equal to 0.
What are we setting equal to 0?
X minus 9.
X minus 9, because that's the denominator. When we do that, we get x equals 9. So how would our domain look? Think back to the first 2 examples.
Parentheses, negative infinity, comma 9,
Mm-hmm.
u for union, and parentheses 9, infinity.
Perfect. When we have a fraction and we set the denominator equal to 0, our domain always looks like this, with the union of 2 parenthesis sets. So whatever number we get when we solve for x, those numbers go right here in the middle. Because this tells us that the function has a domain that includes numbers from negative infinity to 9. So it doesn't include 9, but it also includes numbers from 9 to infinity. There's just that gap right there. Okay. Okay, what are we going to do on 6? What are we going to do on 6? So the square is supposed to be there this time. It's a fraction, so we know we're going to do what? Set the bottom to 0. 4x squared plus 1 equals 0. Okay, we want to get x by itself, so what do we do?
Minus the 1.
Minus 1, so 4x squared is equal to negative 1. What do we do next? Divide by 4. So we have x squared is equal to negative 1/4. How do we get rid of the square? The square root. However, if we take the square root of both sides, what is that going to mean for this negative 1/4?
It's undefined. Does not exist.
It's not going to exist at that negative 1/4. But if we just treat this as our equation, x squared is equal to negative 1/4, is this equation ever possible? Can we plug in a number for x and ever get a negative number?
No.
No, because of that squared, right? Remember, if I told you if we see that square, that's related to what type of function?
Quadratic.
A quadratic, and what is always the domain of quadratic?
All real numbers.
All real numbers. And I will write that out. Never a number that will give us a negative. So the domain is all real numbers.
Put this on YouTube, right?
Yes. Okay. Any questions on number 6? Okay. Number 7. What are we going to do on 7 to find the domain? We have a radical this time, a square root. So what are we doing?
Less than.
Good. We're going to set this inside to be less than what?
0.
0. And why are we setting that to less than 0? Because we can't take the square root of a negative. So that means we need to find where this x value will give us a negative number, and we're going to exclude that in our domain. So if I'm solving for x, what am I going to have?
X is less than 2.
Less than 2, moving that minus 2 over to the other side. Okay. How would I write that as a interval?
Parentheses, negative infinity, 2 parentheses.
Okay. And I just realized I made a mistake here on 7 and 3. So what is this that we're finding? This is when all the values are going to be what? What does less than 0 mean?
Negative.
Negative. So we actually want the opposite of this, because this gives us, and that's my bad, this gives us when all values are negative. So if we want the opposite of that, we only want the positive values, what would our domain look like? Yeah, 2 to infinity. Okay. And again, that's my bad. I'm gonna go back up to number 3. Okay. So number 3, again, this negative infinity to negative 4 gave us all the numbers that are what? Negative. And we don't want negative numbers because we can't take the square root of a negative number. So what is our domain?
Negative 4 infinity.
Good, the opposite, negative 4 to infinity. And again, that's my bad. Forgot that last step. Okay, just think when you're writing the domain, you want all the numbers that are possible, not all the numbers that can't work, that are not included. Okay. And then lastly, number 8. Number 8, we have a function h of x is equal to x plus 6. Any ideas how we would approach this problem to find the domain? Sorry, say it louder. So we wouldn't equal it to 0 because it's not a fraction. So it's not on the denominator, it's not a fraction. Can anyone tell me what type of function this is?
Linear?
It's a linear function. And what does the graph of a linear function look like? A line. Okay. So we can assume, let's say it looks like this. It's a line. If we were looking at that graph and I told you to find the domain, what would you tell me the domain is?
Oh, negative infinity to infinity.
Good, and we would call that
All real numbers.
all real numbers. So just like the domain of a quadratic equation is always all real numbers, the domain of a linear equation is also all real numbers. Okay? And that is unless you see a graph, specifically a graph that has the open circle, closed circle, open dot, closed dot. If you see something like this and they are putting restrictions on it and they want you to tell them what those restrictions are. But if we are just looking at a function goes on forever and ever if it does not include those restrictions. So it would always be all real numbers. And that is it for this topic.